How's it going, everyone? Welcome back to the channel. Today we're going to talk about some more basics of algebra. This is Basics of Algebra Part 2, and we're going to talk about variables. We're going to do a little review on them. We're going to talk about coefficients, like and unlike terms, and lastly we're going to put them all back together and learn how to combine like terms. Okay? Let's first talk about or review what variables are. Alright, so what are variables again? Well, if you remember from my first video, variables, okay, are letters that represent unknown values. Okay, so they represent unknown values, and this is very important if you remember, because in algebra we use variables for everything. Okay, so why am I talking about variables again? Well, that's because I'm going to teach you now about coefficients. Coefficients. What are coefficients? Coefficients are just the number that is directly multiplying to a variable. What does that look like? Well, that looks like this. Let's say we have here 8 times x. So what we have here is just 8 times x. Okay, but we can rewrite this as one thing, and this becomes 8x. Okay, so what we have here now is a variable with its coefficient. Okay, this 8 right here is our coefficient. So what exactly does the coefficient tell us? It tells us how many of a certain value we have. Let's do this for example. So where do these coefficients come from? What do we do with them? How do we find them? What do they even tell us exactly, right? Well, we learned that coefficients tell us how many of an unknown variable, or how many times we multiply an unknown variable, right? How many of an unknown variable we have, okay? Or unknown value we have. So let's take this for example. Here we have one folder, right, with X amount of papers. So just to let us know, I'll write here that X equals the number of papers in the folder. Alright, so we have X number of papers in the folder. How many folders do we have? Alright, so our coefficient in this case equals the number of folders. Well, how many folders do we have here? We have 1. So what is now, so then what can we do with this information? We can take our coefficient, multiply it to the number of papers in the folder, and that'll give us the total number of papers we have. So what do we do with that? Our total number of papers equals coefficient times our variable, which then gives us 1 times x, or 1x. Here we have our coefficients. I'm going to circle that in light blue, and then we have our variable. I'm going to circle that in yellow. Okay, don't forget that. Our coefficient times our variable. Here's a special something about having a coefficient of 1. Alright, a coefficient of 1 can be considered as invisible, or we just don't have to write the 1 next to the x. Alright, so our 1x is the same as just x. So, or 1, if you have you end up with a coefficient of 1, you don't even have to write it, just write the variable. And it will be understood to have a coefficient of 1. What if, then, we have 3? Whoa, we have 3 now. What do we do with that? So we have 3 folders, and each of them has Y number of files. Y equals number of files this time in the folder. Alright, so we know that Y is the number of files in the folder, or in each folder. Okay? How many folders do we have? Well, what does our coefficient tell us? Our coefficient tells us the number of folders we have. How many folders do we have? Well, why don't we number them? We have 1, 2, 3. We have 3 folders. Boom. There's our coefficient. So, how many files do we have in total? How do we find that? Remember that the total files is equal to our coefficient. So I'm just going to put it as co-e times the number of files in the folder. So what does that then give us? It gives us our coefficient 3 times the number of files in the folder, or Y. So that finally gives us our 3 times Y. Okay? We have our coefficient times our variable. And what does this tell us again? The number of files we have in total. What can we do with these coefficients? What role do they play in the wider range of algebra? Well, we use coefficients and variables and numbers to make terms. Now, what is a term? Well, a term is a single mathematical expression. What does a single mathematical expression look like? Let me just give you an example. Let's say we have 3x plus 4 minus y equals 12a. Alrighty, so what do we have here? Well, the term a single mathematical expression, or the word term, refers to anything that is either it can be a single number, a single variable, or a product of a number of one or more variables. Alright, so what does that tell us? What does that mean? Well, first of all, what was that first thing that I said? I said that it could be a single number. Right? Here we have the number 4. That by itself is a term. It's a single mathematical expression. What about a single variable? We have here negative y, right? This negative y is a term by itself. And lastly, we have the product or multiplication, or the multiplying of a number and one or more variables. Just like we have 3x over here, even 12a over here. These are all terms, okay? Just to clarify, a term can either be a single number, a single variable, or a number or a variable in its coefficient. So all in all, this little equation that I wrote here for you, an example, is made up of 4 different terms, okay? What else is there to know about terms? Well, we can break down terms into 2 subcategories, okay? We have like terms and unlike terms. How do we define like and unlike terms? Well, let's look at like terms first. If you remember from above, a term could be either any single number, single variable, or multiplying the coefficient and a variable, okay? Like terms are 2 separate terms that are the same or similar, alright? So let's say we have the term 2x. A term that is like 2x will be something like 3x, right? How about 4y? What is a term that is like 4y? Any number times y. Let's say negative 3y, right? How about a? Let's use a, right? A is another variable we could use, right? What is a like term to a? Well, let's say 5a. So now we have some like terms. Well, what about unlike terms? Well, if you take a guess here, if you said that unlike terms are terms that are not similar or not alike in any way, then you are absolutely correct. Let's take that 2x from before. Well, let's say the term next to it is 4y. Are they the same? No, they are not like terms. Okay, what about, let's take that negative 3y, and the term next to it is just the letter x. No, they are not the same. They are unlike. What about our a? The term next to it, say b. Are these like each other? No. No, they are not. So that's how you find out what like and unlike terms are. Now here's the thing. Later on in a future video, we'll talk more about what we can do with unlike terms, because solving equations that have unlike terms takes a little bit more work. But right now, we're going to talk about what we can do with like terms. Alright? So what can we do with like terms? Well, we can do what is known as combining like terms. For example, let's say we have 3x and 2x. Let's say we decide we want to add them. Alright, so now we have 3x plus 2x. How do we add them? Well, since they have the same variable, okay, they have the same variable, that means they are like terms. So what do we do now, right? We know that 3x and 2x are like terms, and we want to add them together. So all you have to do is add together your coefficients. Well, what is 3 plus 2? That's 5. So when we're able to add our coefficients, all we have to do is take our variable and stick it right next to that 5. So basically, our 3x plus our 2x is equal to 5x. All we did is we added our coefficients together, that becomes 5, and then we take our x, the same variable, and stick it right there at the end. So, what is 3x plus 2x? 5x. Let's try another one. 3x plus 4y. What's the very first thing that we look at? Our variables. Our variables to determine if they are like terms. What are our variables here? Well, we have x and we have y. So are these like terms? No, they are not like terms. Not like terms. Not like terms. So can we add 3x plus 4y? Not able to add. Awesome. Alright. So, why don't we try and apply what we learned today in a little bit more exercise. Okay, 2x plus 7x, 4y minus 5x, 10a minus 8a. I urge you to go ahead and pause the video for a few minutes, give this a try on your own, and then I'll show you the answers right after. What are the answers here? What is 2x plus 7x? What is 4y minus 5x? And what is 10a minus 8a? Well, first, find your variables. If they are the same variable, then they are like terms, and then you can perform the mathematical operation. So we have 2x plus 7x. That should give you 9x. 4y minus 5x are not like terms, so you don't have to write anything. There is no answer. Or you can just say, not like terms. And then you have 10a minus 8a. Well, a is the variable for both, so they are like terms. What is 10 minus 8? 2. So 10a minus 8a is 2a. Hope you guys learned a lot today from this. If you have any questions, remember, feel free to leave a comment down below, and make sure to like, comment, and subscribe. It's such an honor to be able to share this knowledge with you, and I hope you learned something. Thanks very much for watching. God bless you.